Hello and welcome to a new Aurora Devs tutorial for Unreal Engine. In today's video, we will show you how to install and use our new EQS-based player targeting system, Pulse Targeting. First, install the plugin using the launcher and enable it in your plugin settings. Once you've restarted the editor, enable Show Engine Content and Show Plugin Content. If you scroll down to Pulse Player Targeting, you can find the files of the plugin. Inside, there's a demo map we strongly recommend using as a reference. We'll go through most of the features of the plugin now, of course, and the link to the documentation is also available below as always. Pulse Targeting uses EQS queries, which is part of Unreal's AI system, to query the world and find the best target for your gameplay system. The targets are filtered and scored depending on the tests and filters in your query, and it's all purely data-driven. This system can be used for soft lock and hard lock in combat, and it can also be used for interactables and a wide range of gameplay systems. The first thing we'll do is create a targetable enemy. You should already have this in your project. Here we're just removing the things that this enemy class doesn't need, like cameras and inputs. We'll add a pulse targetable component to the enemy, which marks it as a targetable actor. In the component, you can specify which targeting types this actor supports. These can be gameplay tags for things like soft lock, hard lock, interactables, etc. For this project, we'll create a new tag called myproject.targeting. You can specify multiple targetable positions in the component and attach them to bones and sockets. For that, we need to set up the name of the source skeletal mesh component, which in our case is mesh. A targetable component has a default targetable position, the chest for example, and can also have extra ones attached to other limbs for example. In this array, you can add as many extra targetable positions as you want. Each can be attached to a bone or a socket as well. You can define their priority by increasing or decreasing their score multiplier, and you can also choose whether they are enabled or disabled by default. You can also assign a tag to each targetable position, which allows you to query that position in runtime. Now we can place the targets in the map and start setting up the player. The player needs a pulse player targeting component, which sets up and updates the queries. You can have multiple queries each assigned to a different type of target. The queries can run automatically at a fixed time step or on tick, the former being the preferred way. For now, we'll set the update type to none and show we can use the query manually. Let's create the EQS asset and set it up. The query needs a generator which will return all the actors in the level inside a radius that have a targetable component. The radius here is 20 meters. We'll show later how to set it up dynamically. We also need to specify which type of targets we need to look for. Right now, this query will always return the first valid target. We'll show later how to score and filter them. What we'll do now is run the query and draw a sphere on the found target whenever we press the button X. This async node will look through the queries set up in the component with the associated targeting tag, run it, and asynchronously return the best target if any. Here, the wrong execution pin got linked automatically. We come back to fix it later. It should be coming from the onFound path. This returns the default position we set up in the targetable component, which is the chest, if you remember. Let's correct our mistake and test this out. It works, but as you see here, it always selects the same target no matter what. Let's fix that. We can add a variety of tests that filter and score the found targets. Make sure to think properly about which tests should filter, which ones should score, and which ones do both. What we'll do here is add a couple of tests, which prioritize visible targets that are most aligned with the camera. This test will score targets on how aligned they are with the camera. And this one will score based on how aligned they are with the input. Now we choose the best target whenever we press X. Let's try it in multiplayer. Spoiler alert, it won't work. That's because Unreal doesn't instantiate AI systems on the client by default. To fix that, we need to add a command in the default engine ini file. After restarting the editor, we can see it works on the client now. As I said before, we can also skip all of this and let the component take care of updating the query in the background. You can also see Unreal's debugger for EQS by pressing Shift plus apostrophe 4 on the numpad and then the divide key. You can see that the query here is getting updated without pressing anything. Now that the query is ran in the background, in order to access the info of which target is selected by this query, we can use the Get Most Recent Targetable function. If you want the server to also access that information, you can use the commit target function to send it to the server. In our case though, since we're letting the component run the query automatically, all we need to do is check the auto replicate box. Now, we'll do something different, draw the debug sphere on the head instead. To do that, let's assign a tag to that targetable position in the enemy class. As you can see here, the server is drawing the debug sphere on the correct target. So to recap, you can run queries either manually or let the component do it automatically. You can access the current target with find most recent targetable. You can commit it to the server manually with commit target, or let the component do it automatically. On the server, you can get the target with get authoritative target. Now let's show you how to make a giant enemy with multiple targetable body parts. Instead of using the extra targetable positions of the targetable component, each targetable body part will be a child actor component. This is useful for when you want to be able to directly hardlock or target a different body part than the default position. Like, for example, when you want your player to hit the legs of a giant enemy instead of the center. Now you can see every body part shows up as its own actor in the EQS. Now we'll show you how to dynamically set up the search radius of the EQS, so you can reuse them. In the generator, you can set the radius to be a named param called pt.searchRadius. Using that same name in the player targeting component, we'll assign the radius to the value of your choosing. If you've enjoyed this tutorial, please leave us a like and subscribe. If you need help, don't hesitate to drop by the Discord server or send us an email at support@auroradevs.eu. And until next time.